For this example, we want to solve the exponential equation 171 e to the x minus 4 equals 9. In order to solve this exponential equation, I need to have the exponential isolated on one side of the equation. So I'm going to highlight the exponent as well as what the exponent is attached to. This is the expression that I want isolated before I use one of my techniques. So I need to isolate by dividing by 171 on both sides. That gives me e to the x minus 4 equals 9 over 171. Now I'm able to solve this using one of the methods, which is either to convert this to a log or to take the log of both sides. I prefer to take the log of both sides. I'm going to take the natural log on the left and do the natural log on the right. Once you introduce the logs, you're allowed to use the power rule. And the power rule allows you to make this exponent the coefficient of the log. So that becomes x minus 4 times natural log e equals natural log of 9 over 171. Natural log of e simplifies to be 1. X minus 4 times 1 is x minus 4. And the right-hand side, I'm just copying down to be natural log of 9 over 171. Now finally, I can get x by itself by adding 4 to both sides. And I have my solution of 4 plus natural log of 9 over 171. For this question, we want to solve the logarithmic equation. In order to solve the logarithmic equation, we need to have the logs condensed into a single log. So we're going to start by condensing this log base 2 of x plus 3 and the log base 2 of x plus 2. We're going to condense to a single log. And when you condense, you're either going to condense with multiplication or division. And because we have a sum symbol and addition symbol between our logs, we're going to condense with multiplication. That's using the product rule. That's going to give me x plus 3 times x plus 2 inside of our log. So we've condensed using the product rule for logarithms. And based on having a log only on one side of the equation, I'm going to use the method of converting to an exponential. I'll convert to an exponential using the base of 2, the exponent of 1, and this expression will equal what's inside the log. So we've got the equation 2 to the first power equals x plus 3 times x plus 2. I'll simplify the equation. 2 to the first power is 2. And on the right-hand side, we'll multiply that out to get x squared plus 2x plus 3x plus 6. I have a quadratic equation. I'm going to move all the terms to the same side, so I'll subtract 2. And I have 0 equals x squared plus 5x plus 4. I can solve this quadratic equation by factoring. Factors to be x and x, 4 and 1, with both pluses. Now that I have it factored, I can set each factor equal to the 0 using the zero product property. I have x equals -4 and x equals -1. With all logarithmic equations, you need to check to make sure that your solutions are in the domain of your original log expressions. And that means that you're checking to make sure that you never take the log of a negative. So let's check x equals -4. That's log base 2 of -4 plus 3 plus log base 2 of -4 plus 2 equals 1. -4 plus 3 is a negative, and -4 plus 2 is a negative. And so that means we need to throw this solution away. Log of a negative is undefined. Let's check the other solution of x equals -1. In the original equation, we would have log base 2 of -1 plus 3 plus log base 2 of -1 plus 2 equals 1. -1 plus 3 is a positive. -1 plus 2 is a positive. And so -1 is in the domain of our log expressions, and we'll be able to keep that solution. So the only solution to our logarithmic equation is x equals -1. We want to solve the equation natural log of 2x plus 1 plus natural log of x plus 3 minus natural log of x equals 0. So in order to solve this problem, what we want to do is condense these logs into a single log. We're going to condense using both the product rule and the quotient rule for logarithms because we have pluses and minuses. So we're going to condense. We're allowed to condense all of these because they all have natural log. Natural log is base e. And I just noticed that before we can condense, we need to use the power rule. The power rule allows us to take this coefficient of 2 and make it a power. So we would write this as natural log of 2x plus 1 plus natural log of x minus 3, and using the power rule, this becomes natural log of x squared equals 0. Now that we don't have any coefficients, we can condense to a single log using both the product and the quotient rule. This log is positive, and this log is positive. So those factors will go in the numerator using the product rule for logarithms. And this factor is a negative. That log is a negative, and so that factor will go into the denominator. That's using the quotient rule for logarithms. And now that I've condensed to a single log, I can rewrite this log equation as an exponential equation. In order to write it as an exponential equation, I need to know what base is used. Because this is natural log, ln is natural log, we treat this as log base e. So using the definition of a logarithm, I can write this as an exponential equation. I would use base e, the power of 0, equals the expression inside of the log. That's 2x plus 1 times x minus 3 over x squared. Now that I've simplified, I'm going to write e to the 0 is the same thing as 1. And I now have a rational equation to solve. And with rational equations, I want to clear any fractions. So I can clear the fractions by multiplying both sides by the denominator. If I multiply the right-hand side by x squared, those denominators will cancel. And I can multiply the left-hand side by x squared, and that gives me x squared times 1. So my new equation is x squared equals 2x plus 1 times x minus 3. I've gotten rid of the denominator, but I'll multiply it out to the right-hand side. That's 2x squared minus 6x plus x minus 3. If I combine like terms, I'll have x squared equals 2x squared minus 5x minus 3. I have a quadratic equation, and I'm going to move all the terms to the same side. Now I have 0 equals x squared minus 5x minus 3. And as I look at this, I don't think it will factor. So I can solve this using the quadratic formula. I'll let a equal 1, b equal negative 5, and c equal negative 3. So using the quadratic formula, I would have negative. Let me write that out for you guys first. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So using the quadratic formula, I would have x equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times negative 3 all over 2 times 1. We simplify. Negative 5 is positive 5. Negative 5 squared is 25. Negative 4 times 1 times negative 3 is a plus 12 over 2. It's 5 plus or minus the square root of 37 over 2. I need to find the decimal approximation of these so I can check to see if these values are in the domain of the original expression. So I'm going to type into my calculator 5 plus square root of 37 over 2, as well as 5 minus square root of 37 over 2. To get that decimal approximation, I need parentheses around my numerator. That's 5 plus square root of 37, close parentheses for the numerator, over 2. That's approximately 5.5. Can use the feature of the entry. Second enter gives me an entry, and I can change that plus to a minus to get the other one. And the other one is negative 0.5 approximately. And we want to check these solutions to see if they are in the domain of the original function. So we're going to check x equals 5.5. In the original, that's natural log of 2 times 5.5 plus 1 plus natural log of 5.5 minus 3 minus 2 times natural log of 5.5 equals 0. So these are all positives. So that expression will be positive. 5.5 minus 3 will be positive, and 5.5 is positive. So we're going to be able to keep that solution. The other solution of negative 0.5, we'll check that in the original. 2 times negative 0.5 plus 1, that is natural log of negative 0.5 minus 3 minus 2 times natural log of negative 0.5 equals 0. So we get a negative on this log and a negative on this log. I believe this one is positive. But if you have any log of any negative, that is undefined, and so we're going to have to throw away that answer. So we're going to get the only solution to this equation is 5 plus square root of 37 over 2. Thank you for checking out my videos. Have a great day.